Hey guys, welcome back. Mr. Marone here. So we are going to take a look at something that's a huge topic in geometry. We're going to look at proof. And proof is something we're going to deal with in a whole bunch of different ways. And I wanted to start off by giving you the basics of what a proof looks like, and then starting with something you're already comfortable with, which is algebra and solving algebraic problems. So when it comes to proof, what it means to prove something is to use mathematical statements to verify truth. And basically what that means is we're going to have to back up or defend everything that we do. So up until now, you have been able to solve equations based on rules that you were taught. Now we're going to use those rules to defend why we're doing what we're doing. So every proof that we're going to look at, for the most part, are going to be known as two-column proofs. So it looks like what you have right here. The left-hand side are known as statements, and that's all the math that you've already done, which you'll see in a second. The reason column, the right-hand side, is why we're doing what we're doing. It's the why behind the what. And in every proof, they're going to give you the bracket, or you can draw out the T-chart with statements and reasons. They're also going to give you a couple pieces of information. The first one is given. They're going to give you things to start with, some information, some basic stuff to start with. If they don't, you can't prove anything you don't know how to start. So that's the first part. They're also going to give you what they want you to prove. So you have to work with the end in mind. You can see the end. The statement is right there for you, and they want you to prove up to that point. So you have to fill in the middle part, and we're going to step our way through this. So let's take a look at some examples here. And like I said, we're going to use our knowledge of algebra to set the stage for our proof. So in this first one, they've given us this equation. They've told us to solve 2x plus 3 equals 9 minus x. And they want us to prove that x equals 2. So they've given us the answer. What you're going to do every single time before you start doing anything else is to put in three crucial pieces. The first thing you should do is your first statement is what they gave you. So you should write in 2x plus 3 equals 9 minus x. That should be the first thing you do every time. The reason for that, the reason why we can put that in there, our justification is that they gave it to us. So reason one should always be given. The last thing you should do is put in what you're trying to prove. Give yourself something to aim at. So in that bottom left-hand part of our grid, we're going to put in x equals 2. Now, it's up to us to solve it. I'm going to solve what happens to get from step 1 to step 2, and the reason for that goes in reason number 2. So in step 2, what I'm going to do is I'm going to add x to both sides, and I'm going to have 3x plus 3 equals 9. Now, how I got from step 1 to step 2, I'm going to color code that in red for us. How we got from 1 to 2 goes there in reason number 2. So what we did was we added. We used addition. And we would continue on in that same process. So to get to our next step, step 3, I would be subtracting 3 from both sides, and I'd have 3x equals 6. And my reason for that, how I got from step 2 to step 3, comes over here, is I subtracted. Subtraction. To finish this problem off, I'm going to divide both sides by 3, and I'm left with x equals 2, so that means that's step 4. And how I got from 3 to 4 comes over here, and I used division. So on the left-hand side, we're just doing math. We're doing the same math you've always done. On the right-hand side, we're giving our justifications for the math that we did. At this point, I'm going to ask you to pause the video and try the second one on your own. Remember to write in your 3 pieces of information and then solve out from there. Okay, welcome back in. So hopefully you see here that I stepped down as normal on the left-hand side, and what I did from 1 to get to 2 came over here in reason 2. What I did from 2 to 3 came over here in reason 3, and from 3 to 4 came here in reason 4. Just something to point out, how I got from 3 to 4 is using something called the symmetric property. What that tells me is that if I've got negative 12 equals x, we like having x on the left-hand side of an equation, so we can swap those because they're symmetric. It's the same thing on both sides. it's something that we can reverse. You've always been allowed to do that. We now have a reason for it, and there's a chart that's coming up as well. So what you've got here are 2 more examples that I want you to try. And underneath that, on the bottom of your paper, are all these different properties. All these first ones, you know. They're all given to you. You know what addition property is, you know what subtraction is, multiplication, division, you know how all of those work. Substitution, distributive property as well. The ones that you may not have heard of are these geometric ones, which we're going to review in class tomorrow. You're not going to need any of those for these upper proofs here. They're just something that we wanted to highlight for you as well. So go ahead and try those 2 proofs on your own. Remember, this is something brand new, so if it's difficult, that's okay. It's expected to be difficult. Go ahead and try those, and when you come back in, the answers will be there. Alright, welcome back in. So if you noticed when you were starting these, there wasn't a proof, there wasn't a target for us to aim at. That's fairly common when it comes to these algebra ones because you're just solving for algebra. When we get to the more geometric proofs in class and over the next couple days, there will always be something for you to prove. They're not going to be a number per se, so it's going to give you a little bit of extra information to make sure that you're set up properly. So as you see here, these are your answers. The first one is 4 steps. The second one is 5 steps. This one here, this last step where I used the symmetric property, was not required of us because they didn't give us something to prove. I just did it because it tends to feel more comfortable when x is on the left-hand side of our equation. So hopefully this made a little bit of sense. I'm not expecting for this to be this groundbreaking, like you get everything. This is the first time you've ever seen something like this, and this is one of those things in geometry that is very, very different. So take heart that you're new to this. You will get better as time goes on. Have a great night, and bring in any questions you have tomorrow to class.